3x squared plus 2x. And we want to find the equation. So find the equation of the normal line at, what's my point again, 2, 4? 2, 4. Okay, so what does normal line indicate? Jacob, what's normal line indicate?
Perpendicular to the tangent line.
Right, perpendicular. So we'll have perpendicular slope, i.e. what? What does that mean with my slope? Opposites.
Reciprocal.
Yeah, where that starts with the R and ends in reciprocal. So opposite. Reciprocal.
We use calculator.
No. No calculator on the test. Okay, so first off, to find the equation of a line, we use point slope form. So y minus y1 equals m times x minus x1. x1 and y1 would then be 2, 4. So I plug those in. So we've got y minus 4 equals my slope times x minus 2. And how do we find my slope?
Take the derivative of your function and then plug in.
Right, we need the derivative at 2. That'll give me the slope of my tangent line. Take opposite reciprocal, and we're good to go. So let's find the derivative over here. So dy dx. So I need to use the chain rule. The derivative of the square root is 1/2 times. Right, so it's 1 all over 2 times the square root of the inside. Okay, well, we can use the power rule, right? I think of this as 3x squared plus 2x to the 1/2. That turns into 1/2 times 3x squared plus 2x to the negative 1/2. And that goes here, okay? But I think it's easier with the square root. You're just going to run into the square root function all the time. It's better just to sort of be kind of memorize this is the form. Okay, times the derivative of the inside. What's the derivative of the inside?
6x plus 2.
6x plus 2. So I can simplify this a little bit. This will be 3x plus 1 all over the square root of 3x squared plus 2x. What happened to my 2? Right, the 2 canceled with this 2, and that's 6. Give me 3 and 1. And we only care about this derivative at what point?
2.
Yeah. So at x equals 2, dy dx will then equal 3 times 2 plus 1 all over the square root of 3 times 2 squared plus 2 times 2. 7 over the square root of 12 plus 16. 7/4. Hey, by the way, how do I know it's not 7 over negative 4? What does this look like? You know what this looks like graphically? It is because of the square root. If you think of the square root function graphically, it looks, this will be moved somewhere, but it'll look like that. And all the slopes of my tangent lines are all positive there, right? Right, so just think of it that way. If I'd put a negative in front of here, it'd be upside down. It'd be reflected about the x-axis. So we don't have to worry about that. All right, still 7/4. So what number do I plug in to my slope? Negative 4/7. All right, because that is opposite reciprocal of 7/4. Now, if you look at the answer choices, which you can't see on the board here, but they have it in standard form, so it's faster if you just multiply both sides by 7 right now. So don't distribute your negative 4/7, because then when you're working with fractions, you'll probably screw it up. No offense, right? But people in general screw up fractions a lot more often. It just makes it easier on ourselves to multiply both sides by 7 to get 7y minus 28, and distribute the negative 4 on the inside to get negative 4x plus 8. So we have 4x plus 7y equals 36. There's my answer. What letter is that? E? E. Sweet. Any questions about that problem? We can broke it down. Yeah, Tim?
Whenever you're doing the chain, you don't take 6 out of 6 is supposed to be.
How come I don't take the 6 out of it?
Like, that derivative.
Right. So I took, this is the first derivative, and then the derivative of the inside is the part in red.
And then why don't you take the derivative of that?
Oh, because you don't take the derivative of your derivative, you take the derivative of your functions in the original function. Does that make sense? So you're taking the derivative of this inside here, in the part inside here.
Yeah.
You're not taking the derivative of 6x plus 2.
I know, but wouldn't that be part of the chain rule?
All right, so what's part of the chain rule is times the derivative of those x's. So times derivative of x, which is 1. That's kind of what's going on. Not this one, actually. It's going to be this one. That's technically the last part of the chain rule, right? That's your dx over dx. Right, so basically, Tim, you want to stick with your original function. You never take derivatives of your derivative on the chain rule. And I think that will avoid making that mistake. All right, any other questions on this problem? All right, sounds good. Let's go on to the next problem.